All right, everyone, would you believe today is our last week with circles? So last time we talked about arc length, which was finding a portion of the circumference, and today we're going to be talking about sector area, which is finding a portion of the entire area. So if you look at this formula we're given here, sector area of a sector is equal to the measure in degrees over 360 times pi r squared. That should actually look kind of similar to what we did here when we're finding arc length. So let's just look at arc length real quick, review that from last class. Review, what is the length of AB? So if we are looking here, AB is 120 degrees. Our arc length formula was arc length is equal to m in degrees over 360 times 2 pi times the radius times our circumference, our whole circumference. So if we look here, in this case, if we're looking for the length of AB, we know the length is 120 in degrees out of a 360 total times 2 times pi, and our radius here, I forgot to give you one. Let's call this 3 inches. All right, so if this is a 3-inch radius times 3, we can type that all in our calculator, and we end up with 2 pi, which is the same thing as roughly equal to 6.3 inches. So that was how we did arc length. We figured out the degrees, like what portion we're looking for, times the entire circumference to figure out what's left over. That portion is what we were looking for as our arc length. Same idea with sector area. Our area of a sector, so a portion of the circle, that's in this case we have it shaded so you can see that. It's still what portion of the circle are we looking at with this guy. And pi r squared, that is our area of a circle formula, which you hopefully should remember from a little bit ago. So if we're going to use this formula, it's the same idea as what we did with arc length. What is the area of the sector of AB? So this sector here is what we're looking for. Again, it's 120 degrees, just like we did with arc length, but in this case, it's area of a sector. Our degree measure is 120 out of a possible 360. Then we want to multiply that by our area of a circle. So pi times the radius of that 3 squared. Notice how I put my 3 in parentheses because I want to square the 3 and nothing else. So if I do this a step at a time, 120 divided by 360 is the same thing as a third, times pi times 3 squared, that's 3 times 3, which is 9. So if I do a third of 9, or 9 divided by 3, you end up with 3 pi inches, and in this case we're talking about area, so it has to be our units squared. It's two-dimensional when we have area. Notice we have like a length and a width going on here, so that's two-dimensional, inches squared. Or if you want, I type it in my calculator, I got 9.4 inches squared. Either works, either in terms of pi, where pi is in the answer, or as a decimal, also fine. I usually round to the nearest tenth just for everyone's sake. Then there's another example here. What is the area of the unshaded region? Oh, that's such a great question. To do unshaded region, you would do the same idea, except in this case, we would figure out this part that's left over. It's not 120 in this case. It'd be 360 minus 120, which is 240 degrees. So we're going to do 240 over 360 times pi times the radius squared. Notice that didn't change. This is the same here as it is here because we're still talking about the same circle area. It's just what portion we're talking about. Now we're talking about this, the rest of this here. So this is going to be equal to now 2/3 times pi times 3 squared is 9. So in this case, it's going to end up being 6 pi inches squared, which roughly comes out to 18.8 inches squared. You might notice that this has been doubled from here to here. That's because this is a third of the triangle, and this one is at 2/3 of the triangle, so it's just double that. If we looked at the whole triangle, it would end up being 9 pi as our total thing, because we add another third onto that. So that's kind of cool. All right, so that's our first example with sector area. Same idea as arc length, just now we're using area instead of circumference. All right, so if we look here, find the area of sector JK. JK we know is 90 degrees. It gives us right here. That's cool. That's a right angle right there by our central angle theorem, if you remember that. So area formula. Area is the measure over 360 times pi r squared. So in this case, our measure is 90 degrees over a possible 360 times pi times our radius. Wow, I forgot to put a radius again. It's 14 inches. All right, pi times our radius squared. So if I type that in my calculator, it comes out to, simplifies to a fourth times pi, 14 squared is 196. Anyone know that? I hope you did. And then if we type that in our calculator one more time, we end up with 49 pi in terms of pi, which is roughly equal to 153.9 inches squared. Again, inches squared is really important. Area has to be squared units. Last but not least, example 3, find the area of sector LON. So it's, this huge Pac-Man here we got going on. All right, so if we're looking for LON, we're doing it the same way. Area is the measure over 360 times pi times the radius squared. In this case, our measure, wow, I'm terrible at writing these out. I said LN is 60 degrees. Can we figure out what LON is? 360 minus 60. Great, I definitely heard that out there. Nice job. So that's 300 degrees. So our measure is 300 divided by 360 times pi times our radius of 5 squared. So if I simplify this, type in your calculator, you should end up with about 20.83 repeating pi, which is roughly equal to 65.4 meters squared. All right, so you should get some good practice with that this week, and then we will move on to solids next week. Good luck.